Good morning, everyone. Welcome to Math Monday. I'm Miss Barnes, and the segment that follows is Math for kindergarten through second graders. Hi, friends. How are you doing this morning? I'm doing all right. Today, we're going to be working on thinking addition to solve a subtraction problem. So our objective today is I can use addition to solve a subtraction problem. The tools that we'll be using today are a part-whole map and connecting cubes. I have those tools digitally. If you don't have cubes at home, you can use blocks or some of your toys or even pieces of cereal from your cabinet sometimes. So please make sure that you take a moment, get your part-whole map ready, and find a tool that can help you count and solve these problems, and let's get ready to learn. All right, so like I said, our objective today is I can use addition to solve a subtraction problem. Let's jump right into the first one. Remember that when we're presented with a word problem, one of the most important things we can do is read the question from start to finish. So we really need to read it from the very first word to the very last punctuation mark. So let's read this one together. Sully needs 8 tickets to get on the ride at the carnival. He has 2 tickets now. How many more tickets does he need for the ride? Do you remember what the next step is in our process of understanding word problems? The next step is we need to write a sentence that will answer our question. So our sentence should say something like, Sully needs some more tickets to get on the ride. Okay. So that's going to be our answer statement. And we leave the blank there so that we know we have something to solve. Okay. Now the next step in our process is for us to go back, stopping at each punctuation mark and figuring out how to model that problem, part of the problem. So that's what we'll do here. The first thing is we'll go back and we will read sentence by sentence. So starting with the first sentence, Sully needs 8 tickets to get on the ride at the carnival. And there's a period, so we're going to stop there. Whoops. Drew on top of my word. Let's try again. I still kind of did, but we all know that's an H. All right, so we need to think about what this sentence means in the context of our problem. Sully needs 8 tickets. So we know that in a number sentence, there are at least 3 numbers. In our case, there will be 3 numbers. We'll have 2 add-ins and a sum, or we will have 3 numbers that we put into a subtraction problem. We also know that subtraction problems start with the total number of objects that we have. Does 8 reflect the total number of objects that we have? Sully doesn't have 8, but that's how many he should have if he wants to get on the ride. So that number does represent the amount of tickets that he will need in order to get on the ride. So we're going to model that in our part-whole map by writing 8 at the top in the total box. My total box is really small, so my 8 doesn't fit into it, and that's okay. Let's read the next sentence. The next sentence says, he has 2 tickets now. And there's a period, so we'll stop. Tell me, how do I model the 2 tickets that Sully has right now? Well, that's pretty easy on a part-whole map. I'm going to take the connecting cubes, and we'll just drop 2 on the left side of our part-whole map. Now that represents Sully having 2 tickets right now. How many tickets does he need in order to get on the ride? Well, we don't know, so we're going to put a question mark in this side of the part-whole map. You'll see that there's space for a subtraction sentence right below the part whole map. We're going to come back to that later. So remember I said our strategy today is to think addition in order to subtract. So I am seeing this part whole map, and I bet you can tell me what an addition sentence with a missing addend would look like. Remember, the addends are the parts of the addition sentence that are being added together. So let's think about an addition sentence that we can write in order to solve this problem. Looking at my part whole map, I see that on the left side I have 2. And I know that with a part whole map I'm going to add the 2 boxes together, but I don't know how many is here yet. So I'm just going to put that line like we did in our sentence. That way we can solve for it in a little bit. And we know that 2 plus something equals the 8 tickets that Sully needs to get on the ride. So what do we do next? Well, next we need to solve this number sentence. So 2 plus what equals 8? There are a couple ways that we can talk about doing this. I'm actually going to create a more friendly number, and I'm going to break this unknown addend into 2 parts. So I know that 2 plus 3 equals 5, and that something else plus 5 equals 8. So the parts of the missing addend are 3 and something else. Well, now I can see that 5 plus something else equals 8. Well, how do we get from 5 to 8? That's right, we add 3. So 5 plus 3 equals 8, which means if we go back up, 2 plus 3 plus 3 equals 8. And now we have to talk about this part in the middle. So what is this here in the middle? What does that equal? 3 plus 3 equals, well, that's right, great job. 3 plus 3 equals 6. So we know that 2 plus 6 equals 8. Now I'd like to draw your attention back to that subtraction sentence over here underneath the part whole map. So now we're going to talk about how to take this addition sentence and turn it into a subtraction sentence with an answer. Then we'll complete our problem. So looking at the part whole map, can you see the relationship between the 3 boxes and their positions in the subtraction sentence? Let's try. What comes first? I already gave you this answer, so hopefully you were listening. Tell me what comes first in the subtraction sentence. That's correct, the total. So we're going to put 8 here because that's how many tickets Sully needs in order to get into the ride at the carnival. Then we need to subtract the part that we know he has. So going back to the problem, how many tickets does Sully have? That's right, Sully has 2 tickets. So we've already solved this subtraction sentence by creating our addition on the right side of your screen. So we know that 8 minus 2 equals 6. And that Sully needs 6 more tickets to get on the ride. Great job. Take a quick break and a deep breath, and we're going to get started on problem number 2. All right, problem number 2 looks a lot like the first problem that we did, except we're talking about my friend Rhea and her time at the beach. So let's start by reading the problem from start to finish. Rhea has 6 balls at the beach. A strong gust of wind takes 4 balls from her. How many balls does Rhea still have? So I'm going to go back and we're just going to read that again, stopping so that we can model. So Rhea has 6 balls at the beach, and we're going to stop there. What number does 6 represent? Does it represent a part, or does it represent the whole? Good job. So we're going to put 6 at the top of our part whole map. And again, I know mine doesn't fit, but I bet you got yours too. The next sentence says, a strong gust of wind takes 4 balls from her. So over here, we are going to model that the wind took 4 balls. So 1, 2, 3, 4. And we have to calculate how many balls Rhea still has. Okay, great job. So our subtraction sentence, when we are ready to solve it, remember where the pieces of the table go. Our subtraction problem will look like this. 6 minus 4 equals what? Now you already may know the answer to that, and that's great. But in case you don't, we're going to flip the problem and think addition in order to solve this subtraction. Remember, we can use our model here, our part whole map, or you can use the fact that you know makes 6. So we have to think 4 plus what equals 6. Well, let's break this missing number into parts. I know that 4 plus 1 equals 5, and that's pretty close to 6. So this is 5 plus something equals 6. And I know that 5 plus 1 equals 6, which also means that 4 plus 1 equals 6. And I know that this piece in the middle, 1 plus 1, I know that that equals 2. So 4 plus 2 equals 6. So going back to our subtraction problem was 6 minus 4 equals, and now we know that that equals 2. Great job. I've got one more problem to show you today, but we don't have time to solve it. So let me clear my drawings, and I'll just leave it here on the screen for you. I had such a great time working with you today. I hope you keep working this week, and I hope you enjoy the beautiful fall weather outside. It was my pleasure having you in class today, and I'll see you next week.